Alright guys, welcome to the Chapter 7 review. Test will be for you guys this upcoming week. A day it will be on Tuesday, B day you will be testing on Wednesday, so please make sure you study. So let's just go ahead and get started. Okay. Problem number 1, the instructions for 1 through 4, it's that we're going to mark the pictures with the given information. We're going to determine if they're congruent. If they're not, we're going to say CBD, which means cannot be determined. If they are, we're going to say the statement, the congruent statement, and we're going to state the theorem that makes it true. Okay? Alright, so we're going to look at problem number 1. You're told that HJ and DS are congruent. HR and SR are congruent. You should be able to recognize that you have vertical angles here, which means that those two angles are congruent. You have two sides in an angle. However, notice that we have side-side angle, and that is not 1 over theorem. So side-side angle is not a theorem, or angle side-side is not a theorem. Therefore, this is not congruent, so we're going to say cannot be determined, cannot be determined. Okay? Number 2, you have triangles VWU and XUW. What I would suggest is that you redraw them separately, so I'm going to do the following, where this is U, this is W, this is V, this is X, this is U, and this is W. According to the diagram, these are congruent, these are also congruent, and as you notice, when you separate them, they both share this line segment here. One thing you can use as a clue is notice how both of the triangles have the same letters UW, U, and W, so that means that this is congruent to that. So again, you have side-side angle, side-side angle. That's not one of the ones that we can use. Therefore, this is not congruent, cannot be determined. Okay? Problem number 3. This symbol tells you that these lines are parallel and this line is parallel. Remember that when you have parallel lines cut by a transversal, alternate interior angles are congruent. So what that means is that this angle here is congruent to this angle because they're on alternate sides of the transversal and they're on the inside of the parallel lines. And this angle is congruent to this angle. You should also notice that if you were to take these triangles apart, the line here in the middle is being shared by both of them, which means that it would be congruent. Okay, so if you redraw them, you would have something similar to the following, where this is S, Y, C, C, H, S. So we said this was congruent to this, we said this was congruent to that, and now we said that this is congruent to that. Now it is obvious for you to see that this is side angle, so they are congruent. So now we got to make sure we write our congruent statement correctly. CYS. In order to write our congruent statement, remember that we need to match corresponding angles. So C has the 2 hash marks, which means that I need to use S. Y is this angle here, so that will be the H. And S is the one with the 1 arc, so I'm going to match it to C. So triangle CYS is congruent to triangle SHC. Excuse me. Problem number 4. M is the midpoint of AB, which means that if it's the midpoint, it is splitting this entire line segment in half, which then tells you that this is congruent to that. If you redraw this triangle separately, this is A, M, C, C, M, B. This is congruent to that. That's congruent to that. And now you should recognize that this line is congruent because it's being shared. So this is side, side, side. And now we just gotta say CAM. So CAM, CBM. Triangle CAM is congruent to triangle CBM by the side, side, side theorem. So that is going to be a yes. Okay. Let's flip the page. Just wanted to let you know you can pause the video as you need, so I'm gonna move a little fast, but if you need, pause the video. Alright, first thing I want to talk about in this page is we have not talked about this, so we're not going to use it. Okay? This is coming on chapter 8. Okay? So let's just take it one by one. Okay? So let's look at the piece of information that you were given. You were given two sides and an angle. So your options are either side, angle, side. That's the only option that you have with involving two sides. Okay? In order for this to be true, you need to have an included angle. Remember, an included angle, it's an angle that's in between the two sides. So I'll give you an example. Here's one side. Here's another. This angle right in between. Notice how the two sides join here. This is the included angle. Okay? Now, as you can see, this angle is not in between the two sides, so it's not included. So therefore, it's not side, angle, side, which means that this is side, side, angle, which is not something that we have. So this is going to be none. Okay? Number 8. We have a side and an angle on both of them, so we're going to need to find a third piece of information. You will notice that they're both sharing this line segment, so that means that it's congruent. Okay? So now look at one triangle individually. So let's take a look at the bottom. That is side, angle, side. Side, angle, side. So they are congruent by the side, angle, side congruence theorem. Okay? Number 9. Congruent, and then these sides are congruent, and that's all you're given. But you should be able to recognize that these vertical angles are congruent. Therefore, you have two angles and a side. So you can either have angle, angle, side, or angle, side, angle. Okay? This side is a non-included side, which means it's not between the two angles. So therefore, we have angle, angle, side. Number 10. Everything is marked for you, so just look at what you're given. This is not an included side. So that means that this side is not in between the two angles, which then means that you have angle, angle, side. So they are congruent. Number 15, you should have no problems recognizing that these two triangles are not congruent, so we're going to say none. 16, you have an angle, you have another angle, and there's their corresponding angles being congruent, and you should recognize that they're sharing a side, so that means they're going to be congruent, so that is going to be angle, angle, side. If you need to redraw this triangle separately, please do so that you can better see the two triangles and you can compare them. Okay. 17, it's a little hard to see, but you can tell that this angle is congruent to that angle, and this angle is congruent to that angle. By now you should start to catch on. Anytime you see a side being shared by both of them, you see this side, if you were to split the two triangles, okay, they would both possess that line, which means that this would be congruent. So you have angle, side, angle. Okay. Number 18, you have that this angle is congruent to that angle, this angle is congruent to that angle, and that side is congruent to that side. Angle, angle, side. So these aren't too bad. Okay. Alright, number 19, everything is marked for you. Angle, side, angle. Number 20, these two line segments are congruent, this one are congruent, and they're sharing one, which means it is congruent, so I'm going to put 3 hash marks. So side, side, side. Number 21, remember that this symbol means that the lines are parallel, and when you have a parallel lines cut by parallel lines right here, cut by a transversal, this angle will be congruent to that angle because of alternating to your angles, and the angle here would be congruent to this angle there. Okay? Alright, some of you guys may want to say that because these are vertical angles, you're going to want to go ahead and mark them, but I would want you to stop and not do it because all you need is 3 pieces of information. Okay? As of right now, you have an angle, a side, and an angle. That's enough. Okay? So with that, I actually already gave you the answer. You have an angle, you have an included side, and you have an angle. Therefore, this is angle, side, angle. Number 22. This angle is congruent to that angle. They're both sharing that side, so we know that it is congruent. Okay? We do not know anything else, so we're going to say none. We cannot assume that this is a right angle. Okay, we cannot assume that this is the right angle, so we're going to say none. Alright, we're going to skip question number 23, and that's going to take us to 24. It says, we are going to need to add another piece of information in order to prove the triangle's congruent by this postulate. So in other words, in order to prove this angle, side angle, okay, let's look at what they gave us. They gave us a side and they gave us an angle. So a side and an angle, so we need to find another angle. It's got to be a very specific angle. You only have two choices. It can either be angle A or it can be angle ADV, which would be right here. But only one of those will make it angle, side, angle. The side has to be included. So that means that this side has to be between the two angles. So here's an angle, which then leaves you with only one option. Angle A. Angle, side, angle. So angle A is congruent to angle C. Alright, 25, you have side, angle, side. We have a side, we have an angle, we have a side, we have an angle. So that means we're looking for a side. So you have two options. It's either this one, BA to AD, or AC to AE. Only one of those will satisfy side, angle, side. This angle has to be included. So that means it has to be in between the two sides. And use the acronym to help you out. Notice how the angle is in between the two S's. So if that's an S, that's the angle, then that leaves us with no option other than this AC is congruent to AE. Angle, side, angle. Side, side, side. Alright, this is the only thing that's given to you, but not really. You should also recognize that they gave you this line segment here in the middle. They're both sharing it, so it's congruent. Therefore, we only need to find the third side, and that's our last option. That would be that this line segment is congruent to this line segment, so I'm going to call it BC is congruent to BD. Alrighty, let's go ahead and flip the page. If you need to pause the video, don't forget to pause the video. Number 27. We're going to rotate the HJKL 90 degrees counterclockwise about the origin. There's multiple ways to do this, so I'm going to talk about all of the methods possible. 27 and 28 are similar, so I'm going to mention one of them in this, and then I'll talk about the other method on this. Okay? So one of the methods that we talked about in class was to actually rotate the paper, but remember that if it says to rotate counterclockwise, you're going to rotate your paper opposite. So if it's counterclockwise, so your clock typically goes this way, so here's what you're going to do. You're going to rotate your paper clockwise. Ready? That's how the clock turns. And you're going to plot your coordinates on this quadrant here. So let's talk about it. Okay? L was at 3, 4. So when I rotate, I'm going to do 1, 2, 3, 1, 2, 3, 4. And that's going to be, we're going to call it L prime. I'm going to go back. K is located at 8, 4. So I'm going to rotate. And I'm going to say 8, 4. And that's going to be K prime. Alright. H is located at 3, 7. So I'm going to rotate 3, 7. And that's going to be H prime. And lastly, we need to do J. J is at 8, 7. So I'm going to rotate, and I'm going to do 8, 7, and that's going to be J prime. I'm going to connect my vertices, and voila, you have rotated rectangle HJKL 90 degrees counterclockwise. So that's one method. The other method is that if you're in quadrant 1, remember all of your vertices are going to be positive, so your X and your Y, all of your points. When you rotate, okay, notice for example, I'll give you L as an example. L was located at 3, 4. Okay, L prime It's located at negative 4, 3. So here's what happens. The x and the y, notice how the x was a 3 and the y was a 4 originally. Well, guess what? Now the 4 is here, and now the 3 is here. So if you notice, here's what happened. The y became the x, and the x became the y. So all that happened was switch. But because you're in quadrant 2, you know that the x value, which is denoted by the y, became negative. So if you think about it, it was x was 3, y was 4. When you flip them, it becomes 4, 3, but you gotta make the first one negative because you're in quadrant 2. So I like this method. I would recommend using this because all you gotta do is switch back and forth. So in here, if this is xy, then here this would become yx with a negative because we're in quadrant 2. And then if we were to rotate here, then it would again go back to xy, but because you're in quadrant 3, they're both negative. If we go on this quadrant one more time, then that means that it's going to be back to yx. But because you're in quadrant 4, you will then notice that this would have to be negative. So I want you to notice what happened. You have xy, yx, xy, yx. So it alternates. My suggestion would be to just add the negatives by remembering which quadrant you're at. You know that quadrant 1, they're both positive. You know that in quadrant 2, it's negative, positive, negative, negative, positive, negative. Okay? Alright. Number 28. It says we're going to rotate the parallelogram 180 degrees counterclockwise. The other method that we learned in class was to use the hook method. And this is how the hook method works. Okay? You would go 2 units. And then I went 4 units. Okay? You know that you're going counterclockwise, so that means you're going in this direction, and you're doing 180 degrees, so that's 90, 180. So that you know that your answer should be somewhere in here. Notice how we first went along the axis 2 units, and then we went up. We're going to do the same thing. We're going to go 2 units, and then 4. And that would be where W prime is located. Okay? Alright, I'm going to switch colors, and we're going to do Z. Z is going to be 7 units, and then 2. So now I'm going to say 7 units and then 2, which would be right here. So we're going to call that Z prime. Z prime. Okay? Alright, we're going to do one more. So I'm going to try to switch colors. Let me see if I can find a different color. Alright, this should work. Got some green. So we're going to do 2 units, and then to go all the way to x, that is 9 units. So 2 all the way to 9. This is going to be x prime. And lastly, we're going to do y. So let me get a different color. We're going to do 7, 7. So here it is, 7, 7. So I'm going to say 7, 7. There you go, and that's going to be y prime. I'm going to go ahead and connect all of the dots, and voila, you've just rotated parallelogram WXYZ 180 degrees counterclockwise using the hook method. Okay. Alright, 29. We're going to reflect the parallelogram DEFG over the x-axis and over the y. Reflections are very easy. Here's what I suggest. For example, take a look at point F. What I would do, let me zoom in a little bit. I would start here, and I would count the number of units I'm going to the left. 1, 2, 3. So you're going to do the same thing, but not go to the right. 1, 2, 3. We're going to call that F prime. We're going to do the same thing, but for E. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We're going to call that E prime. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's G prime. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that would be all the way here, 9. That's D prime. We're going to connect them. And voila, that's your reflection over the y-axis. Okay? You do the same thing for the reflection over x. Notice how it's going down. You can use this to help you out. You went down 4 units for F and for E. So I'm going to go down from here. I'm going to go to the 4. And from here, I'm going to go to the 4. Okay? Notice how this one is at 6, so that means you went down 6 units. So with the G from here, I'm going to go all the way to 6. And with D from here, I'm going to go all the way to 6. And this one is F double prime, E double prime, D double prime, and G double prime. So there's your reflections, which leads us to the last part of our review, which is lines of symmetry. Okay, 30. This one, if I go vertically, this would match exactly. If I go horizontally, you will notice that the eyes will not match the mouth, so there's no other way. So the only lines of symmetry is this one, so we have one line of symmetry. A circle is very interesting. If I do a line there, it will be symmetric. There, 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 there. I could draw an infinite amount of lines, and it will be symmetric along that line. Okay? This one right here, if I draw a line there, it will be symmetric. If I draw a line there, it will be symmetric. Interestingly, if you go diagonally, it will be symmetric as well. And if you go here, it will be symmetric as well. So that's 1, 2, 3, 4 lines of symmetry. And lastly, we have this thunder here. And there is absolutely no way that we can have this as having reflectional symmetry. Okay? Rotational symmetry, one thing you need to remember is that it has to be less than or equal to 180 degrees as far as the angle of rotation. Okay? So for example, look at the smiley face. If I rotate 90 degrees, it doesn't look exactly the same. If I rotate 180, it doesn't look exactly the same. So it doesn't look exactly the same unless I rotate 360. But according to definition, it has to be less than or equal to 180. So that means that this one is no rotational symmetry. Look at the rectangle. If you rotate 90 degrees, it's still a rectangle, but it looks a little different. But if you rotate 180, it looks exactly the same that it did when we started. So this one is yes, and it would be 180 degrees. The mathematical way to do this is you would have a line of symmetry there, and you would have a line of symmetry there. That's two lines of symmetry. A full rotation is 360 degrees. If you divide 360 by the number of lines of symmetry, which in this case was 2, 360 divided by 2 is 180. That's your angle of rotation. Okay? This one is actually very simple. If you rotate 90 degrees, it will look exactly the same. If you rotate another 90 degrees, it will look exactly the same. So that means that this one will be yes, and it will be every 90 degrees, so 90 and 180 degrees. The thunder will be a no. Check this out. No matter how I rotate this paper, it does not look the same until I rotate 360 degrees. Okay? Alright, class, that's that. Please study. Please make sure that if you have any questions, email me. This is a great review to get you ready for that test. Again, don't forget that I also gave you that cheat sheet during class. That would be a great cheat sheet to study for your test. Thank you for watching, and I'll see you next week.